Hello, everybody. In this video, I'm going to discuss abstract classes and the object methods toString and equals. Okay, so let's discuss abstract first. A class can be abstract if you use the keyword abstract before class. Now this becomes an abstract class. Even though you do not have abstract methods, none of them are abstract, that's fine, as long as you put this keyword there, okay? Once it's abstract, you cannot instantiate an object from it. So now this statement becomes invalid because person is abstract and you are trying to instantiate person. That's not okay, okay? So let's do this. I will put another method here and delete this abstract keyword. So now this class has an abstract method. Once you have an abstract method, your class must be abstract. Otherwise, it will not compile. Okay, so the basic principle is that an abstract class does not have to have abstract methods. But as soon as you have an abstract method in an abstract class, you must make that class abstract, okay? So now this will not compile, right? Because you have to give it a body. So now this is okay, okay? So that's that, you understand that? What did I want to do? Okay. So let's talk about this walk method, okay? I'm going to just delete this. So remember, an abstract class can have non-abstract methods, right? It doesn't have to have abstract methods. Okay, let's put them here. And I will do Control, Shift, and C, okay. Control, Shift, and C will uncomment them. So now let's have a method in this abstract class. So first of all, why do we make this class abstract? When you have a class that's so generic, that's so general, it is meaningless to instantiate any object from it. What you do is you simply use it as a placeholder, as a repertoire where you can store the attributes for all the child classes, where you can store some methods, common methods. But the class itself is too general, too generic to instantiate. For example, a person, it's very general because every person is actually a special being, okay? We are not talking about politics here. I'm just talking about this general sense, okay? So a person can only be a student, elementary school student, a professor, a worker, a farmer, a soldier, etc. So it has to be a specific person, not a generic person. And once again, I'm not being political. So don't think, let's not talk about human rights or society or anything like that. I'm using this as an example to illustrate hierarchy, the inheritance hierarchy. Okay, so that's when you make this class abstract. Okay, so once this class is abstract, you cannot instantiate it, right? You can only inherit it. So student can still inherit person. And so now let's run, let's see. Remember, we do have a walk method here, right? So many people, and now you see that you cannot do that. So you have to comment this out and comment this out, right? Okay, So now we run and we can actually call s1.walk. Let's see what it does, right? So it will go to the abstract class and call the walk method, you see. So even if it is an abstract class, it can still do all kinds of things. The methods can be used by its child class. Okay, now I'm going to do this. I'm going to make this walk abstract. Okay. And as you know, this will not compile because it's not abstract. It must have a body. So we make it abstract. And now if I delete this, you will see it will not work. It says this is an abstract method. You must make the class abstract, right? So I'm going to put it there. Undo. Okay, so this abstract method walk doesn't have a body because we don't know how a specific person walks. So let's go to the student class and define that. Because student inherits person, it must define the abstract method. So we will do, I have it here. Okay, let's do this. Okay, I'm going to decomment, right? Okay, so when you have the super walk, this must be when it's not abstract. Okay, if it's abstract, you don't have that, right? So what we do is we can say walking with a backpack, right? That's a student, a specific student will walk that way. Let's see. I have some error. Let's see where the error is. Oh, janitor. Janitor has to, because janitor inherits person and person has an abstract method walk, so you have to define it. If you don't define it, you will not compile. So that's something that we discussed in the, oh, I cannot do this. We discussed in the lecture notes, okay? So, okay, so now we can actually run. And if you look at janitor walking with a cleaning cart and broom. Okay, so let's run. So this is walking with a backpack. That's the student. I did not call janitor. So j1.walk. Okay, let's run. Okay, so that's that, okay? Now I will change this abstract method to a method that's not abstract, okay? So abstract, change it to not abstract, and then I'm going to define it. And this is really what we discussed in the previous video already. But I will just do this one more time. Okay, walking. So now it's not abstract, right? This method is not abstract. So here in student, we actually can call it because it does exist. So we call walk first, and this will be printed out, walking, and then we add to it, walking with a backpack. Let's run. Okay, so this part is the person method, super.walk. And this is the this is the statement specific to the student class. Okay, and janitor, I did not call super.walk, so it doesn't have that. It's just this one statement, and that's what is there. Okay, so that is the abstract method. Abstract class and abstract method. To summarize, you cannot instantiate an abstract class. And if you do, an abstract class does not have to have abstract methods. But as long as you have an abstract method, the class must be dubbed as abstract. Okay. So that's that. The next thing I want to discuss is the methods in the object class. We discussed in the lecture notes, object is the ultimate parent of all classes. So any class, if you do not inherit from anything, you still inherit from object. So this person class, it doesn't have a parent. Implicitly, its parent is object. So object has three methods, okay? ToString, clone, and equals. We don't need to talk about clone because it's not relevant to us right now. So we will only talk about ToString and equals. ToString, we have already done that in the previous video. So you always override the ToString method to make it applicable to you. If you do not define the ToString method, okay, how about this? Let's not define the ToString method. If you do not define the ToString method, it will print out this object ID. Okay, I'm going to take this abstract off so that we can instantiate it. And you can see, okay, so I commented out the ToString method. And then this will not compile the ToString, super ToString. Huh? It didn't say that. It should. Let's see. So here we actually can do that, right? And what we want to see is we want to see what this print out. Okay, let's run. Okay, yeah, the ToString, the super ToString in the student class is calling the objects ToString method. And you can see the ToString is for person, it's this, and the super will go all the way to object, and it calls that method and concatenate that with the string for the student or janitor. So it does compile, but it's calling the objects ToString, okay, which is returning the, I don't have to format that, right? Which is returning the object ID, okay, everybody? That's why we say, once again, you always need to override the ToString method in your class, okay? So, okay, so the ToString, we are done. Now let's talk about the equals method. The equals method is the same. If you do not define it, can you use it? You can. You can still use it. Okay. So let's see. Let me let's do this. If okay. So if you don't define the equals method, can you use it? Yes, you can. What does it do? Let's see what it does, okay? So here, notice that we did not define the equals method, but we can call it, it compiles, right? S2 is student 2, S1 is student 1. They don't have the equals method. If you look at that, they don't have the equals method, but we still can use it. Why? Because the object class already has it defined. So let's run. Okay, S2 is not S1, and that's correct. Because S2's name is Sabrina, and English S1 name is Carl, 23 COSC. How about this? How about we make them the same? And C, age is 23, and this is COSC. Now, they should be the same student. because that's how we define a student: name, age, and major. So if they are all the same, then it should be S2 is equal to S1. Let's see. It still says S2 is not S1, okay? So that's the problem, right? The problem is when they are equal, it should return true, but it still returns false. Why? Because in object, it if you don't redefine it, it compares the two addresses actually, and the two addresses are not equal, right? It compares the two object IDs. So that's why you always should redefine the equals method. And let's do that. How do you define the equals method? Okay, this is how you do it. I'm going to just go back. Okay, let's look at this equals method, and I'm going to explain it. Okay, so equals method returns a Boolean. It accepts an object, the same object you want to compare with, right? You cannot compare apples and oranges. You can only compare a person with a person, and this is the person class. So you are comparing with another person. So how do you know if two persons are the same? You look at the instance variable. How do you define the person? Name and age. So if they have the same name and the same age, then they are the same person in our project. Once again, we are not talking about the society or a broad view of people, of person. We are only talking about in this very narrow project, our person is defined only by name and age. So if those two are equal, then those two people are equal. So we compare name and age, right? Get name, this P is this P, right? The given object you want to compare with. So if they are equal, get name dot content equals, you can say equals, or content equals, and equals are basically the same, except content equals also compares string buffers and string builders, which we will not cover. So if the names are the same and the ages are the same, right? We have this object and we get the age from that object compared to the age of our current object, which is the instance variable. So we compare those, and this name is our instance variable. That is the current object's status. If they are the same, we return true. If they are not the same, this statement will not execute. And we go to the next statement and we return false. So notice that we didn't use else. Can you use else? Yes. Do you need to? No. The reason is these are two statements, okay? So if this statement doesn't execute, if that return true doesn't execute, return false will. If return true executes, it already returns. So the second statement will not execute. Return means going back. Once you go back, whatever is left behind is behind. It will not execute. So that's why you do not need the else. Okay. So now we can see if the two students are equal. Okay, let's change this to English. So now you can see S1 and S2, they have the same name, same age, but different majors. Are they the same? Let's run. They are the same. They are the same based on our design, our implementation. Why? S1 and S2 are student objects. You go to student, do you have equals? You don't, right? So where does the system go? The system goes to the parent. Does the parent have equals? The parent does. So it will use this equals method to compare the two. And this equals method only compares name and age. And here, these two objects have the same name and the same age. The major is ignored. It's not compared. So that's why it says they are the same. Let's change the name. Okay, now it should say S2 is not S1, right? Let's see. They have different names, and S2 is not S1. So our implementation of the equals method is correct right here in the person, okay? Now, since student has a major, so to compare two students, you really should compare the name, age, and major. So we should override the equals method in the persons class. So, okay, here is mine. Let's put it here, and you can do Control, Shift, and C to comment or uncomment, or decomment, uncomment, not sure which one. Okay, let's look at this implementation. So, because a student is a child class of a person, we first compare the person because that's already done. We do not need to go to the trouble to compare, go through the trouble comparing the name and age. It's already done in person. So we simply call that method. Okay, we use super, which references the parent class person, equals, because person has the equals method S, right? Here we are comparing two students. So the parameter is student. And if the current object who has major and name and age is compared to this person's name and age, if that's the case, we also need to compare the major. And that's how we do that. S.getMajor dot content equals, it automatically changes. As I said, it's okay. They are basically the same. Okay. So you compare the two majors, and this is the current major, okay, for this current object. And if those three are all equal, you return true, else, or if that statement doesn't execute, you return false. And let's see how it, what it does now. So I'm going to change, okay, let's run it once. They will not be equal, right? S2 is not S1. And now let's set this to call again, and this to COSC. And they're equal, right? So how about, don't set it to COSC. We make it English. So just now remember, before we implement the equals method in student, when we only use the equals method in person, this will say they are the same, right? Name and age. Now we implemented our equals method in student. So now they should not be the same because they have different majors. And S2 is not S1, they are not the same. So you can see that's how you implement the equals method. Another thing I want to tell you is that I keep saying the current object. So in this statement, what is the current object? The current object is S2 because you are using S2 to call the method. So S2 is the current object. S1 is the object that is compared, being compared to. So, okay, so therefore, if you use this statement as an example, here, this would be S1. This would be S1. Let's see. Yeah, this would be S1. And this major would be S2's major. Okay. So that's, and this would be S1's major. This would give you S1's major. This would be S2's major because S2 is the current object right here. That's what we meant when we say the current object. This is the current object, okay? So this is the current object. Okay, that's about it, right? Let me see what else I want to show you. I think I think we did everything. Yeah, I changed it a little bit without doing all this. So we did everything already. Okay, everybody, that's the equals method. I think we are done. I'm going to stop here. Let me see. Yeah, I'm done.